Walk onto almost any modern industrial site, and you are immediately surrounded by a visual perimeter of compliance. Mandatory hard hat zones, high visibility jacket requirements, ear protection warnings. These mandates exist to counter the physical hazards of industrial work. If we look at the top 10 most common workplace accidents, we see the expected risks: slips, falls, and the manual handling of heavy materials. But look closely at number 4. Injuries caused by inadequate personal protective equipment. If this safety equipment is federally mandated, heavily regulated, and readily available on site, why is the gear itself still a primary driver of injuries? In the hierarchy of industrial safety, personal protective equipment serves as an engineered barrier of last resort, a final, wearable layer of defense, triggered only when a physical hazard cannot be removed from the environment. The preferred axiom of occupational health is that hazards must be eliminated entirely through engineering controls. Remove the danger from the workspace first, rather than managing it with wearable gear. The necessity of wearing a respirator implies that the environment has not been controlled. Dangerous electrical energy, toxic chemical spills, or falling debris are still active in the workspace. Historically, worker safety relied heavily on personal vigilance. Management provided basic slogans and standard issue gear, placing the burden of survival on the individual worker's focus. Today, the challenge isn't simply acquiring the gear. It is the complex, programmatic discipline of correctly evaluating hazards, assigning the right tools, and managing human behavior. Treating protective equipment as a universal shield ignores the reality of its limitations. It is a highly vulnerable secondary barrier that is entirely prone to systemic failure. In the mid-1990s, OSHA forced a shift in how industries handle safety gear. They introduced specific standards requiring comprehensive, documented protective programs instead of general equipment use. Assigning gear now requires a formal hazard assessment. This process relies on the subjective judgment call of the safety and health manager to determine exactly what is needed for specific jobs. This chart shows the appropriate PPE for various hazards, demonstrating how different industrial activities require specific protective interventions. Notice the relationship between the hazard source and the physical threat. Impact work produces flying fragments. Furnace operations produce hot sparks. Because the threats are distinct, the required gear is distinct. High-temperature exposure demands a screen or reflective face shield, whereas handling acid requires chemical splash goggles. Selecting even a slightly wrong variation of a device for a specific hazard negates the protective barrier. A screen shield will not stop liquid acid. Safety managers face a logistical challenge trying to standardize these complex judgment calls across massive, multi-hazard plants, where workers constantly move between different environments. A piece of equipment is only protective if it perfectly matches the precise physical nature and severity of the hazard it is designed to defeat. Getting the engineering right is only the first step. The second is the psychology of enforcing its use on the factory floor. Imagine a complex plant layout, divided into active hazard zones and standard safe zones. As a worker moves through a normal shift, their need for protection constantly fluctuates based on the zone they occupy at any given moment. This creates an administrative trap. Management often feels the temptation to mandate safety glasses everywhere, even in safe, non-hazardous areas, simply to ensure uniform compliance. This overprescription creates a behavioral risk. Workers lose respect for the policy when they know the gear they wear is unnecessary for their specific area. This disrespect leads to uneven, relaxed compliance when that same worker actually enters a true active hazard zone. Arbitrary blanket safety rules increase systemic risk by degrading human compliance and trust in the safety program. We see this friction between compliance and behavior clearly in hearing protection, where physical discomfort directly leads to equipment failure. There is a vast array of available noise protection, ranging from single-use earplugs and molded caps to full aviation headsets. The primary metric for choosing any of these devices is raw effectiveness. How well does the material reduce the decibel level of noise exposure? But the sound attenuation properties of the most advanced materials are irrelevant if the physical fit to the user is poor. Look at how a sound wave behaves when it encounters a compromised barrier. acoustic energy behaves like a fluid. A single tiny leak or microscopic crack destroys the overall effectiveness of the noise enclosure, letting the pressure wave bypass the insulation entirely. Fit is directly tied to human behavior. If the gear is awkward or uncomfortable, employees will take chances, remove it, and become exposed. Equipment efficacy is inherently limited by the human wearing it. A barrier must survive both the physical hazard and the psychological tolerances of the worker. This dynamic reaches its limit in the most extreme occupational hazards, atmospheres designated as IDL or IDLH. These are strict designations. IDL implies a single acute exposure will result in immediate death. IDLH implies an exposure will result in irreversible damage to health. This includes exposure to hazardous materials like hydrogen fluoride gas or cadmium vapor. These hazards are insidious. They can produce transient effects where the victim feels normal for a day or two, followed by a sudden, fatal collapse 12 to 72 hours later. Protecting the respiratory system against lethal atmospheres has always demanded rigorous equipment, from the full-face gas masks of the mid-20th century to modern supplied air respirators. Surviving an IDLH environment requires absolute, unbroken barrier integrity. There is zero margin for a poor seal or a loose strap. In this environment, simply handing a worker a mask is useless. Survival requires an entire ecosystem of protocols governing that mask's use. In these extreme environments, a respirator functions as a vital life support system. Its integrity depends on a perfect alignment of both mechanical components and administrative oversight. This is why OSHA requires a strict 9-step blueprint for a functional respirator plan. It serves as the model for systemic safety. It starts with intensive preparation, equipment selection, medical evaluations to screen personnel, and precise fit testing to match the human to the equipment. Then come the operational mandates, standardized procedures for use, strict maintenance schedules, and the physical provision of supplied breathing air. Finally, the continuous loops, ongoing employee training, practical use instruction, and the perpetual evaluation of the entire program itself. This diagram shows the simplistic view of personal protective equipment as isolated pieces of clothing, but physical gear is useless without a management framework. Hand protection requires hazard assessment. A respirator requires fit testing and maintenance. This brings us back to the top 10 workplace accidents. Inadequate PPE remains a leading cause of injury because organizations buy the gear but fail to build the mandatory 9-step systems around it. Workplace safety is not achieved at the equipment supply depot. It's achieved through rigorous hazard assessment, precise physiological fitting, and relentless programmatic evaluation.